TREX is the Center of Excellence for Computational Quantum Chemistry. It's a place where the chemists, physicists, and the computational scientists meet together in order to make the scientific application, the scientific codes, more efficient, and in order to deal with the next generation of supercomputers. This will allow this community to find a solution to the most challenging problem in this scientific area. That's why TREX is very important also in the ecosystem of the Europe computational scientists. I work in different work packages, and in all of them I work mainly in addressing the evolution of the codes, and here I help the code developers to address the performance-related issues. So the aim is to make the codes in TREX more efficient. And this will help us to have very optimized codes, and those will be codes that will run much faster on the state-of-art technology. In addition, on another part of this project, I will also address the issues coming from the user communities. So I will support the user help desk that will allow the users to understand which is the optimal way to use the codes for their calculation. We have several kinds of stakeholders. First, for sure, the end users, because at the end of the project, we will have a more efficient code, so the end users will be able to perform calculations in a shorter time, and they will be able to afford more complex scientific problems that were before TREX not so easily solvable. Second, the code developers, because they will benefit from the support coming from the technological side of TREX. So all the computational scientists working in TREX will help the scientific code developers to implement in a more efficient way their algorithm. Finally, I think that also a category that will benefit from TREX are the industries that will have new tools for their R&D activities. So this will open up also a possibility of working together with industries. The technological evolution is running very fast. In 3 years from now, we will have in Europe the first generation of pre-exascale machines, and we will be working to have the first exascale architecture. So we will have a lot of computational resources, and TREX will help us to have codes and applications ready to deal with this generation of supercomputers. So that will permit to face problems, challenges in the scientific domain of computational chemistry that are in this moment not possible to solve on realistic timescales. Also on the side of technological, so the HPC world, in TREX we have examples that permit to exploit at the best the computational power of the new machines. For example, quantum Monte Carlo is known as one of the algorithms that can be considered like a killer application. We can think about one single application running on one of the pre-exascale systems. That means that for one single calculation, we could exploit up to 100 billion operations per second, which is dramatically more than what is possible right now. Well, TREX will make possible what is now very, very difficult, if nothing.